Thanks, Dave. Hi, everyone. Welcome to our fourth briefing for this summer series. So I'm Claire Spillman. I'm based in Melbourne at the Bureau of Meteorology, and Alistair is going to kick us off. So I'll pass over to you, Alistair, to get us started.
Thanks. Hello from Nipaluna, Hobart. As usual, we'll just start with a quick recap of what we've covered in the previous briefings. And again, while it's not always so interesting to go back and look at a weather report from last week, each of the briefings contains some information that we hope helps you to become better interpreters of ocean forecasts. So for me, that's the value in looking back at the topics that we've covered. On the 31st of January, we looked at 2024 in perspective and how it had shaped up since the October period. As well as providing the typical update on current conditions and outlooks, we focused on the Western Australian marine heatwave, which is illustrated in the plot to the right, where you can see very dramatic heatwave conditions, strong and severe on the heatwave category scale off the northwest coast of Australia. We described what responses had been in Western Australia so far in terms of what had been observed in impacts, and also the communication steps that were being taken in these regional briefings that followed this national effort. And again, to remind you, this is a nationally focused briefing, and there are state-based and regional briefings that cascade from this effort. And for example, a Northern Australia briefing planned for next week, which was deferred as a result of Cyclone Alfred. When we think about describing the ocean, we have a very strong reliance on satellite-based information because the satellites can give us a synoptic or a whole-at-once view of what's going on in ocean conditions. And they've been particularly important in describing extreme heating events or extreme cooling events because the temperature is very well resolved from space. And so things like the suite of satellites that get popped up by Japan, the EU, or the US provide the basis for much of what we observe in the ocean at the moment. But we know that that's only a very shallow surface picture. And it's really important to understand how heat is distributed in the ocean. It's that amount of heat that does things like supercharged cyclones, lead to mixing events that then affect the biology, and then, as I'll show you shortly, can lead to heat waves lasting for an extended period of time. The schematic on the left has depth on the y-axis, which is termed pressure here. As you know, the pressure gets higher the deeper you go in the ocean. So pressure on the y-axis, and then the anomaly on the x-axis, with left of the dotted line being cooler than average, right of the dotted line being warmer than average. And we've identified with a global community at least 4 types of marine heat waves. In the first plot, there are shallow marine heat waves where the heating is only at the surface, and that comes from the atmosphere, sunlight, high pressure systems, lots of heat going into the ocean, and it's really the surface layer that warms up very quickly. Those events can be broken down very quickly too by strong wind events or by storms that pass over them. Similarly is the case for subsurface heat waves, which are often generated by warm or cold eddies that move hotter water into an area. The ones that are particularly concerning and we need to pay a lot of attention to are the ones on the figure C and D of those vertical plots, where the temperatures are extended quite a way below the surface and much warmer than average, because they can retain heat even when we have winds blow over the surface and lead to other mixing and cooling. And it would be really great to have a much better view of what's happening below the surface, because that would help us with prediction and also understanding the impacts. Each of these 4 types that I've just described appear in different parts of the ocean. And so the series of maps on the right-hand side show where different types of those 4 heat waves are most commonly experienced. And so have a look at the 2 that concern us a lot, C and D. In the third plot down on the right-hand side, they're the subsurface intensified. And you can see red colours off Eastern Australia, which shows us that we quite often get that deep warming off the East Australia coast. We also get that very deep warming in the Eastern Pacific and also in parts of the Western Indian Ocean. Similarly, type D happens to the southern part of Tasmania in the bottom of those maps there. And so just having a sense of what type of heat wave we commonly get in those areas can really help us to add more value to just the surface pictures that we describe. So Australia is making a very big effort to get more information about subsurface heating. You can see how it makes a difference in this example here from 2 heat waves that were observed off the west coast of North America. the top one on the left in 2014 and the bottom one in 2019. And they look kind of similar in terms of that surface expression. But on the right-hand plot, I've shown you again depth on the y-axis and then the years on the x-axis. And in that first event in 2014 and 2015, we can see red temperatures extending quite a way into the ocean. And between the 2 years, 2015 and 2016, there's surface cooling. But the heat that was retained in the ocean at depth allowed that second year to recharge very quickly from the bottom, and we had an extended heat wave that lasted for more than 2 years because the heat was stored at depth. In the final example of 2020, though, the heat wave there was quite a shallow one, and the heat didn't extend to depth, and as we subsequently learned, it didn't persist for multiple years. And it would be great if we could get this kind of data for around Australia, so we could put the events into this context of how much heat is being stored at depth. And Australia is investing in deeper ocean observations. We have moorings around Australia from the IMOS National Reserve, National Reference Stations. We have gliders that are being deployed at different locations around Australia, again through an IMOS program that's letting us look at the structure of marine heat waves in real time. FRDC has sponsored a project called Fish Soup, which is helping to deploy instruments on fishing gear so we can get real-time measurements of what's happening at depth in the ocean. And finally, on the right-hand side, the profiling Argo floats that drop down to about 2,000 meters in depth, drift around for about 7 days, and then take a profile as they come back up to the surface to transmit that data. So we're starting to get our hands on a pretty good set of data around Australia for understanding subsurface structure. And I hope over the next few years you'll see the value of that data collection paying off in paying off in terms of what we understand about the deep ocean and the heat content that's in it. And that's why when we come in this briefing and talk about the distribution of heat at depth through some of the new products we're developing, you'll get an appreciation for why that matters.
Okay, thanks, Alistair. So stepping now into current ocean conditions. So what's been going on in the last week or two, including some info on what's been happening at depth. So we'll start off with a bit of a recap of the last couple of months. So the last briefing was the end of January, and so we didn't have all the data hadn't come into the Bureau by the end of the month then. So you can see here, just if we go over to the right, this shows the average temperature in the surface. So we're just talking about the top layer of the ocean around Australia. It's the hottest on record for January and February as a whole. So that is the hottest January of all the Januaries since 1900 and the hottest February of all the Februaries. Given that's the hottest time of year for the majority of the coastline, those are very warm conditions. If we look at it in terms of a map, here on the left, this is for February. So it's taking that same data and just looking at it around Australia. So you can see this light orange colour is in the top 10%. Temperatures above the 90th percentile, or in the top 10%, is the threshold we use for a marine heat wave. So you can assume that the majority of the areas that are light orange or dark orange here are in marine heat wave conditions. I'll show you more on that in the next couple of slides. But it's just showing that for the most of Northern Australia, all of the WA coast and parts of the New South Wales and Victorian coast, are in the top 10%. And a lot of the Bight, parts of Victoria and Tassie were actually the hottest on record in February. So it's very warm, and that's been the story for this whole briefing series, pretty much, that is warm for the bulk of Australian waters. We look at just the last week, and it's always useful to take a bit of a step back and to see what's going on around Australia. You know, the Australian waters are driven by what's happening in the Pacific and what's happening in the Indian Ocean. So you can see this very warm signature here. Again, surface, anything that's pink is warmer than you'd normally expect for this time of year. Anywhere that's blue, there's not a lot of that on here, is cooler than you might expect. So very warm across Northern Australia, WA, extending offshore into the Indian Ocean, parts of the Bight, and across the Tasman Sea. It's very warm. Sea out here in the Pacific, and I'll get to ENSO in the next slide. There's some warming in the Eastern Pacific and some cooling in the Western Pacific, but there's no big strong signature there. The other thing to point out is cool in the Coral Sea at the moment, or it's around normal conditions. If we have a look in terms of marine heat wave conditions, so top 10% of temperatures, you can see that matches with that pattern I was just describing. So Northern Australia, down the WA coast, through the Bight, all marine heatwave conditions. Parts of WA, so around Ningaloo, Exmouth, and Pilbara region, were at strong to severe marine heatwave conditions. There's also a few areas around the Kimberleys that are showing up as strong marine heatwave and in the Bight. Coral Sea, no marine heatwave conditions there at the moment. And there's a few little patches just off the southeast coast. So that was the surface. Now, if we look into the water column, so this is the top 300 meters. So I'd be keen for a bit of feedback on some of the subsurface information. We've had a rethink about how we present it. So this again is an anomaly. So we take what we'd normally expect for this week, and we look at whether it's warmer or cooler. Over the top 300 meters, this is looking how much warmer it is over that water column than what you'd normally get. So for example, here on the northwest coast around here, we're up to 2.5 or more degrees warmer than what you would expect. And given how shallow this is, that is all the way to the bottom, to the shelf. It is also 1 to 2 degrees warmer all around northern Australia, and that is down to the bottom, well, that's down to a depth of 300 meters. So if it's an area that's shallower, it's the full water column. We can also see it on the shelf around the Bight and around Tassie as well. So as Alistair was saying, that subsurface heat, it's sitting below the surface. So it's going to take more than a couple of windy days to mix any of that heat we're seeing at the surface down. All right, so TC Alfred, so there are plenty of people in Queensland and around the Brisbane area doing it tough. The last couple of weeks, there's been a lot of rain and a lot of attention on this cyclone. So the reason I wanted to show it here was just the effects a cyclone like Alfred can actually have on the sea surface temperatures. So the cyclone started up here in northern offshore in the Coral Sea around the 23rd of Feb. And this is what the sea surface temperature anomalies looked like for that week prior. They were pretty warm up here where the cyclone started and warm for a lot of the Great Barrier Reef and the Coral Sea. As the cyclone moved down the coast, as it moved south through the Coral Sea, so we're at the 26th of Feb here, and it sort of wandered down here by the 2nd of March, that corresponds with this map, that period. And you can see here, the water here in the Coral Sea at the surface is a lot cooler than it was the week before. And that lines up very nicely with that track of the cyclone. So you've got wind, cloud, and rain is all working to cool the surface. Then we get down to the last week, so 1st to the 7th of March, which is when the cyclone was hanging out here offshore, off Brisbane, and you can see there was further cooling. So that really nicely illustrates the effect a cyclone can actually have on the sea surface temperatures. So it's not a get out of jail free card if there's a big marine heat wave, but it can give some respite depending on the cyclone, how big it is and how long it's taking to travel down over the ocean. So that's also relevant for how we went in the forecast we showed at the end of January. So these are the two forecasts, two fortnightly ones, one for the end of Jan, start of Feb, and then one for the middle 2 weeks of February. The top two of the forecasts, the bottom two are the same dates corresponding in observations. So one thing you might notice is the model did a pretty good job for most of the coast. There was a bit of cooling here though in February that the model overestimated. It said it was going to be a lot warmer up here than we actually saw. So again, possibly the work of a couple of cyclones. These were a fair way offshore. So this is on the west coast. So Talia was at the end of January, halfway through to Feb. It travelled off in this direction. And then we had Bianca from the 18th to 27th of Feb, and that travelled sort of offshore and around here. And the result of the combination of those two cyclones was that you can actually see some cooling up here in the surface. So the model forecasts that we're showing can't predict tropical cyclones or their tracks. So it's important to go back and have a look at, how did we do these in the forecasts, but also to understand why they might be looking different to what we thought, say, a month ago. Other than that, the model did a good job of predicting that this heat from on the west coast was going to extend down to the south west coast, which we can see here. It was very warm through the bight, which we can see in the forecast and in observed, and that heat was persistent. And a lot of that is coming from that heat down in the water column, that depth is that heat is at depth. We look at marine heat wave categories again at the surface. They're a pretty good match. That's based on the maps in the previous slide. So you can see there was cooling, or there wasn't marine heat wave conditions here off northwest WA like predicted because of the cooling due to the cyclones. You can see it there in particular for the mid 2 weeks of February. Otherwise, the model did a good job of capturing the marine heat wave conditions down the WA coast and through the bight. We step forward now, so we're going to look from March through to May. What's ahead of us? Okay, so taking a global picture, you can see this is the average for the next 3 months. So again, anywhere that's pink, warmer than normal. Well, there's virtually no blue on here, so there's not many places that are going to be cooler than normal. We can see these warm conditions on the WA coast. Despite those 2 cyclones, it's predicted to continue for the next 3 months on average. It's also very warm Tasman Sea and through the bight, continuingly warm. The difference for these 2 different regions is that for most of Australia, the warmest time of year would be January, February. West Coast, the warmest time of year is actually April. So we're looking at marine heat wave conditions going into the warmest month. We consider ENSO is neutral at the moment, so it's not a La Nina, it's not an El Nino. The Bureau's model is in agreement with the other international models that we survey. You can see here for April, May and June, all the little bars which correspond to those models are in that white area, which means it's neutral based on the ocean indicators. The Indian Ocean dipole has very little influence on Australian climate at this time of year, and it's neutral. So there are no big climate drivers acting at the moment and influencing the forecast. It's the starting point where the oceans are very warm that we're seeing reflected in the forecast. So looking at rainfall and air temperature, and for those that are new to these briefings, we always look at them, particularly if you're working very close inshore. It's good to know what's going on, but also that if it's going to be very wet, there's a lot of cloud, there's a lot of wind, and so the ocean temperature is going to be cooler. So this is for April to June. So this isn't including the rain that was associated with TC Alfred that we've seen in the last week at Brisbane. But on the left is it going to be wetter than usual? And on the right is it going to be really wet? So there is an indication that across Northern Australia it will be wetter than normal for April through to June, but probably not extremely wet. So the one on the right is it going to be in the top 20%, what we normally see for this season? There's a slightly elevated chance, but it's not going to be extreme. Everywhere else in the country, it looks pretty much what you would expect for that time of year in terms of rainfall. Air temperatures, this seems to be a pretty consistent story from the whole briefing series. Chance of it being warmer than usual for daytime temperatures for April to June, pretty much yes everywhere. On the right-hand side, is it going to be extremely warm? And so you can see parts of WA in particular reflecting those very warm ocean temperatures that we're seeing at the moment. Tassie's looking very warm for April through to June, and also parts of Queensland as well. Okay, so getting back into the water. So we're going to have a look for the next 2 fortnights. So given that we're scarily halfway through March, I've got the next 2 fortnights. So the next one is from the 11th to 25th of March. Top panel is our sea surface temperature anomaly. So again, top meter of the water column. Is it warmer or cooler than normal? Red is warmer, blue is cooler. And you can see that heat is extending all the way from Northern Australia, so up around Darwin, all the way down the WA coast, through the bight and across to Tassie. So it's particularly warm here on the northwest shelf for the next fortnight. We've got temperatures that are 2 to 2.5 degrees warmer than you'd normally see this time of year. And also around Spencer Gulf and heading round to Western Victoria. On the right hand here, these little green plots here are showing how good the model is. So anywhere that's green, the model does a good job of predicting this time of year based on the last 40 years of forecasts. Anywhere that's white, it doesn't do a great job. So the model does well for this particular fortnight, which is the top panel. Looking at marine heatwave conditions, these temperatures here are warm enough to exceed that threshold for marine heatwave. So we're still seeing strong marine heatwave here on the northwest shelf and around Exmouth, and then marine heatwave conditions full coast of WA through the Bight. We're also seeing conditions up here off the Kimberleys. If we go to the next fortnight, it's a pretty similar story. Some of the heat has moved south on the west coast, so it's not quite up as warm up as around the Kimberleys, but rather we're seeing those warmer temperatures extending down from Exmouth past Shark Bay, and we're up around 2.5 degrees warmer than normal. That's exceeding the marine heatwave threshold again for the next fortnight, and it's a very similar pattern. Other than the Coral Sea, the majority of the Australian coast is in marine heatwave conditions, or predicted to be for the next 4 weeks. Okay, so once we get out of March, we're into April now. Reasonably similar story. So we've got sea surface temperatures at the top. The same area in WA is still lighting up here for April. So from Ningaloo, Exmouth, Shark Bay and south down to the Cape. Through the Bight. So I would be also keen to hear from South Australia folks if you've been seeing because it has been warm in this area for quite a long time. See if there's been any impacts. And you can see that reflected over here down in the bottom right in your marine heatwave conditions. So persistent marine heatwave conditions down the coast through the Bight. There's some areas of marine heatwave conditions in the GBR, but this is not the hottest time of year for those guys. So whilst it's warmer than you'd expect for April, April's generally not the time of year that people are concerned about bleaching in the reef, particularly because the last couple of months haven't been that warm. The top panel up here is just showing we run 99 forecasts and we look at how many of them are saying marine heatwave conditions. Dark green means 80 to 100% of the forecasts are indicating marine heatwave conditions. And you can see those persistent areas that we keep talking about, WA and the Bight, around Tassie, all very high probability of marine heatwaves. If we actually get into the water and we're looking down to 300 metres, we can see here it's very warm off the coast here. So it's recharging that surface expression you can see of the marine heatwave down the coast here and also down through the Bight and the coast. Tassie. Similar story for May. Not a lot has changed other than that maybe the peak values for heat on the WA coast have moved further south again. So they're around Ningaloo and Shark Bay. It's still warm up here in the Kimberleys and Northwest Shelf, but the bulk of the heat is further south now. Same areas through the Bight and Tassie. Pretty similar pattern actually. I did actually have to check that I'd put the right months in here because they do look quite similar to April. Looking over at our model accuracy or skill, it does drop off. We're trying to predict further out into the future. But for the most of the coastal areas, you can see they're green. So the model historically has had good skill in predicting those temperatures. Not much skill here on the New South Wales coast. There's a lot of eddies traveling around here, and they're pretty hard to get in the right location for the model. Marine heatwave conditions, same areas, WA, Bight, and around Tassie. And I'll pass back to Alistair now for around, so we're going to talk on the sea change project and also some responses. So Alistair, back to you.
It's pretty apparent from what we've just seen here that Western Australia is still in phase 3. We're still experiencing marine heatwave events. And so the actions that are probably taking place around reefs and fisheries in Western Australia are around assessing the impacts and adapting any ongoing activities in both either fisheries or aquaculture or conservation. Tasmania and the east coast of Australia, while there might be some lingering heatwave signal there, because the temperatures are generally cooler now at this time of year on the east coast, are clearly for me in this recovery phase here. And it's a chance to start thinking about how you're going to prepare for the following summer, and particularly if we are able to think about the heat that's maintained in the ocean over this warmer winter period, it will kind of just kick us off from a higher baseline next summer. If we had a cool winter, then it will take longer for that heat to build back up again. So I think again, damn this climate change business, but like last year, we're going to have a lot of heat over the winter that will then set us up for conditions of extreme temperatures again. The last summer, was a real anomaly though. Some analysis that's just come out in the last week said that the conditions that were experienced over the summers of 23 and 24, so that's the Northern Hemisphere summer and the Southern Hemisphere summer, the warmth that we saw was basically a 1 in 500 year style event. The plot on the top left-hand side shows the percentage of the ocean that experienced marine heatwave conditions either in the open ocean or in areas close to the coasts in those two different colours. But largely it shows you that the 2024, the final year in that time series, was unprecedented compared to previous years. And the coloured map in the middle shows locations that had the most heatwave days that had ever been recorded in that region. And the different colours just represent different geographic regions for counting that. So the most marine heatwave days or the top 10% of days. Beauty, thanks Claire. The next one. And so what did we see around the ocean? And the reason we look at this is because we can learn lessons in Australia from what others are doing. This widespread series of marine heat waves, and now this map here shows marine heat waves everywhere they occurred, even if they weren't the hottest that had ever been seen in that region. And so this is where we show a very large portion of the ocean experienced marine heat wave conditions over these year 23-24 summers. And often they were compound events. Compound means two things happening at the same time. So we saw a heat wave plus a cyclone, or a heat wave plus an atmospheric heat wave. Or we saw coastal flooding in areas that were also having heat waves off the coast. That's going to be a problem for the future when we have two of these things going on at once. The responses that we saw around the globe varied, and each of the dots on this map here indicates a response that was observed in three different categories: a biological response to a heat wave, a physical response, including those compound events that I've just described, or a societal impact on the users of the ocean. And so the different colours on the map just correspond to those kind of examples. What was interesting are the triangles, and that's where people got information or experienced a heat wave and did something different. And there were 7 different kind of interventions that we understood happened around the world, indicated by these triangles. But almost all of the interventions were reactive. There were very few places around the world that were proactive, and only 4 of them, we could only identify 4 of them. Australia had proactive responses, of which the rescue of the red handfish in southeast Tasmania is, I think, becoming a real example of what forecast information can do to aid conservation efforts. So we had forecasts issued in Australia and we were able to have responses. Similarly, the northeast of the US had a prototype forecasting system, and that was used to aid some coral conservation efforts around the Florida area. It's a real worry that even when we do have forecasting capability, that there's not going to be more that we can do. And so in the next slide, it describes some of the responses that the way in which these responses can flow through. And so again, if we think of the stages of marine heat wave, before we have a heat wave, when we have a forecast, when the heat wave occurring, and then after it has receded. In this case, it's a 7-step model, but it's really a 4-step model with a bit more detail. The handfish conservation project kicked off before the heat wave hit, and so that's why it's called a proactive response measure. In contrast, in Peru, they had some reactive response planning. Once the heat wave had commenced, they then took some actions that would, I hope, have led to better outcomes for the fishery. And the table on the right just gives you some examples of what happened at each stage in the handfish case in the middle column, or the Peruvian anchovy fishery in the right-hand column. I hope you think about this later on your own. What are the ways in which we can think about doing these different interventions? And that publication there provides some examples from around the world of what people did in response to these extreme events. They didn't happen very much though they weren't reported in the published literature. They were reported in newspapers, in grey reports from conversations with managers and conservationists. And so it's a real challenge in gathering that information and using it. And so there, as an example of a project that's attempting to do more of that in Australia, is called Sea Change. This is led by Greta Peckel from the University of Tasmania. And the Sea Change project, which commenced a couple of months ago, is looking at bringing together fisherers, aquaculture, industry, managers and researchers to try and get a better handle on what are the impacts of climate change, including extreme events, on our production systems in Australia. The Sea Change project will work with end users around Australia. It will try and produce more information packages, maybe more in depth than this briefing here provides, and then develop risk assessment tools that will give the practical suggestions on what to do in the face of this changing climate. Go to the next slide. They're taking a case study approach and looking at how different fisheries around Australia have responded to historical change and how they might be set up to cope with future change. I understand from the team that they're hoping to do 12 case studies, of which they've selected 9. If I could count all those species on the map, maybe there would be 9 locations in which these case studies are taking place, but some of them might involve multiple species. They're going to kick off with a set of workshops and look at lots of, again, engagement with stakeholders there. And in doing these case studies in particular regions, it does come at a cost. So the project is looking for co-investment to expand the range of areas that they can consider around Australia. The team's asked us to promote that today and ask online listeners to contact them to suggest or discuss particular case studies. The next slide, when you receive the presentation, or if you're quick enough with your mobile phone now, you can grab the QR code and that will put you in touch with the team here, which is also producing a range of products that can help us to understand both the impacts and the options for responding to change in the ocean. As well as us suggesting that there were regional briefings that accompany these national briefings. Again, we'd pump the FRDC Extension Officer Network as being a place to go to for information and to get more guidance on what's happening in your particular ocean region. And again, the contacts are listed in the presentation from around Australia. Thanks, Dave. We'll hand back to you and Felicity, please, for questions that you might have. And if you're leaving early, thanks very much, and we'll see some of you at the 5th briefing on the 2nd of May, which we should be well through the critical period that Australia's experienced this summer.
Thanks, everyone.
Thanks.